Okay. So A5 DNS and normal DNS working the same, guys. Okay. The only difference is A5 has some intelligence features. A5 is intelligent device, like we can do load balancings. A5 DNS is going to be monitor the pool. Pool is basically the VIP, and accordingly it is going to be give the IP to the users. But in case of normal DNS, like local DNS or whatever normal DNS we are using, that feature is not available. Okay, we can also use DNSSEC features. So DNSSEC features is not only a specific for F5. Okay, it is mm, in short, I can tell like DNS has no any security. Okay, so with the help of DNSSEC, we can secure our DNS. So how it will work? I'm not going to explain in detail, but just giving overview. For example, this is the user, this is the users, and he's trying to access www.facebook.com, right? So instead of the actual authoritative server where Facebook.com IP is binded, maybe someone in the middle try to give the IP to these users, and user will start communicating with the bad IP, which is not good things. So to avoid such types of things, we use DNSSEC to protect our cache poisoning attacks. Okay, so we'll see DNSSEC in the last chapter. Then we'll see global server load balancings, and then what is data centers and server object, DNS virtual server, DNS pool, wide IP. So we'll see in details, including example also. We'll see like in our lab. So first question is like for you guys, why DNS required? Just give your output here. Why DNS is required in our networking domains?
Basically, it's a result of the domain name to IP address. Hello.
Yeah, yeah, yeah.
Yeah, basically, actually, whenever user enters any URL in the browser, so the user machine try to resolve like a domain name to IP address in the web cache. And if there is no any entry in the web cache, then it will check the host file, right? If there is no host file, then it will send the DNS query to our local DNS server. The local
Okay.
DNS devs try to resolve, right?
Yeah, yeah, you are right. So just one thing I want to hear. For example, if anything we are accessing, for example, www.facebook.com, just for examples. See, if anything we are accessing, so what is the first lookup? First, always look up a DNS lookup. There are so many types of lookup we'll see in details. There are so many query also like iterative query, recursive query. What is that? So if you are accessing any website, any application, first party DNS lookup, then three-way handshake, then SSL handshake, then actual data get transferred in between source and destinations. So in short, I can tell if DNS is not there, it is very difficult to reach on the internet, very difficult to go on the internet because we need IP to communication for the communications. PC cannot communicate with FQDN. PC can communicate with IP address. So for that, DNS is very, very important. It's play a vital role in our domains. So if DNS is compromised, we can say lose our internet, lose everything. Because without DNS, we can't access any applications. Because we can never communicate with FQDN. We always communicate with IP. Okay, so that is the reasons. If anything accessing, we need IP, then we can communicate with that. So for that purpose, DNS is required. Whatever you are telling, that is the lookup, like how DNS lookup happens when you are accessing any browsers, any application on the browser. Okay, so this is how DNS is required and how DNS work basically. So I'm just explaining overview. We'll see in details. Don't worry about it. So for examples, you are accessing anything like whatever Najib said. For example, www.facebook.com. So first part is basically check like whether any uh, before local DNS. Generally, check the host file also, like is there any entry for that URL. So host file entry generally we put, for example, there is a inside application. That application is not allowed on the internet, and there are some less people in the organization who is trying to access that applications. For that, we can manually host that entry inside the system itself, and while trying to access that application, you get the IP from there and it will start communicating it as per the routing and policy, whatever the design of the network. So if anyone try to access anything, first part is basically check like if there is host entry for that. If not, then it is going to be check if the cache for that. And then if there is no any cache entry in local DNS server, then local DNS server will start sending the request to the root server. Root server basically, just 1 minute, let me just, if you run this command, I think you guys already aware it because you are working professional. So these are the cache file, guys. Okay, so these are the cache file already stored in our machines. So, for example, if anything you are trying to access and that entry is available here, for that it will give the IP address from there itself. It is not going to be sent to the all the process like root server, then top level domain server, authoritative server, then again local DNS server, then sent to the users. Okay, so for examples, let's consider there is no entry for www.facebook.com with our local DNS server. Then it is going to be sent that query to the root server. So as per my knowledge, there are 13 root server totals overall in the world. 13, I need to check it, but whatever I know. So for example, just consider this is our actual application, www.facebook.com. See, at the end, they really always dot mention, but it is not visible. So if anything's local DNS is going to be sent, that will go to the root server. The root server is going to be till, okay, I don't know IP address of www.facebook.com, but I know where we need to go. That is called iterative query. So I'm going to explain in detail like what is recursive query and what is iterative query. Okay, so then again, local DNS server is going to be sent to the I need IP address of www.facebook.com to the top level domain server like .com, .org, .net. So these are the top level domain server. Then top level domain server is saying, okay, I don't know IP address of www.facebook.com, but I know who is the authoritative server for that. Then again, local DNS server is going to communicate with the authoritative DNS servers. And then we can say like authoritative DNS server is going to tell, okay, I don't have IP address, but I know who is the actual authoritative DNS server, actual name server for that applications. Then local DNS server is going to start communicating with that server. Okay, I need IP address of www.facebook.com. Then that which is authoritative server, name server is going to provide the IP address to the local DNS server, and local DNS server is going to be maintain that entry in its cache and then send that IP to the client, and then client start communicating with that IP address. When next time this client coming to the for the same applications, this part will not happen because already it's entry maintain its cache file. So when these people come or another people coming for the same applications like www.facebook.com and that entry is already available in local DNS server cache file, then the DNS server is directly going to provide the IP address to all the users. Okay, so then user will start communicating with facebook.com like three-way handshake, SSL handshake, and whatever data generally request like chat, messages, video. So this is the short, we can say like summary about like how DNS work. Okay, in case of F5 guys, in case of F5, so in case of F5, so let me show here a little bit about. See, in F5, how many things we can achieve? Like we can DNS security. We have global server load balancing. What is global server load balancing? Let me give a little bit overview. We'll see all the things in detail, guys. This is just the overview. I'm starting from here. Okay, so that we can understand it. Now this one. Okay. So just consider this is the diagram. We'll try to implement same types of topology in our lab. So let's consider. Let me just take the pen also. Okay, so just consider this is the client, like maybe you or maybe me or maybe Purushottam's. So you guys are we are trying to access www.facebook.com, and this client request, when you trying to access www.facebook.coms, that will request go to the, of course, first part will check host entry, then cache to go to local DNS, and local DNS will start communicating with the root top level authorities. Once it will get the authority, in authority we generally put the listener IP of the F5 DNS. That request will come to the F5 DNS. Then F5 DNS, we created wide IP there. 1 minute, guys. We generally created wide IP. We'll see in detail on wide IP. Wide IP is basically FQDN. So for www.facebook.com, we'll create wide IP with the same name, www.facebook.com. Then wide IP, inside wide IP, we generally put the, let me just see. And for example, just this is one data center. This is in India. This is in US. I'm explaining on the basis of GSLB, Global Server Load Balancing, so how it works. For example, this client is from India. He tried to access www.facebook.com, that traffic come to the F5 DNS. It will come, it is going to be checked either in wide IP for that FQDN. Yes. Inside wide IP, we generally called our VIP, which is created on the LTM box, not the GTM box. So GTM is just for the DNS. Okay. So whatever VIP you have created on our LTM box, just consider this is LTM1, this is LTM2 for India data center. This is LTM1, LTM for the US data center. So we generally create VIP here, right? VIP is the actual IP which is binded with the Facebook.com. Because our F5 load balancer is work on behalf of the actual application, right? So let's consider this is our LTM boxes. We have created VIP here, and then we have the backend server. We have multiple backend server which is handling the traffic for the Facebook.com. So when traffic come to the wide IP, F5 DNS, it is going to check either a wide IP configure for Facebook.com. Yes. Inside wide IP, how many pools are called? Okay, inside we have two pools called. One for this LTM, second for this LTM. Pool is basically VIP IP which is created on our LTM box, and VIP IP is the actual IP which is binded with a facebook.www.facebook.com. That is the DNS entry we can say. So F5 DNS is going to be check, okay. It is going to be check the status, like this is the beauty. Like if it is down, for example, 2 members in the pool, if this is down, it is not going to be give the IP address of this LTM box VIP. It is going to be give the IP address of this LTM box VIP. And this IP will provide it to the users. Now this user will now start communicating with this VIP as the normal process, like whatever normal load balancing do, like 3 handshake, SSL handshake, and actual data get transferred from the backend server. So DNS role is still providing the IP address of the VIP. After that, once user get the IP address of that VIP, we can say like DNS entry, it will start communicating with that LTM boxes, and LTM boxes is going to be give the resources which is hosted behind our load balancer as per the load balancing method, like round robin, or there are so many load balancing method. Just consider this user is from the US. So this is the beauty of F5 DNS. It is, or as per the user geolocation, it is going to be identify the locations of the user, and when that query come to the F5 DNS, F5 DNS as per the geolocation send that traffic to this data center. So inside wide IP, it is going to check, okay, this user coming from US, we have wide IP configured for Facebook.com. Inside wide IP, we have called two pool, and that pool basically is the VIP IP, which is configured on the US data center LTM boxes. And then it is going to be give any IP address as per the availability, as per the health monitors, as per the health. And then this user will start communicating with this VIP, and then it will come to the backend server as per the load balancing method which we have configured. So this is the short overview about GSLB, like global server load balancings, which we will implement in our lab. We'll see live example like how we can do that in our labs. Let me know if you guys have any questions.
No, sir. Yeah.
Iterative query means response only, right?
Yeah,
Hello?
let me explain that also. Let me explain that. See, always this is our PC. Client means what? Client means like this is our browser. So if you are accessing any, for example, for example, I am accessing here just www.facebook.com. So this browser we consider as the client. Okay, so I log in it. I log into facebook.com
Yes.
because I'm getting IP address fastly, maybe because it's caches in our local DNS, whatever DNS. In my case, if you see here, and IP config /r. My DNS server is 1.1. 1.1 is basically my home Wi-Fi router. So it is acting as a it is acting as a local DNS server. So that server is already the cache of the facebook.com. Now come to the your pound like iterative query and recursive query. So when our client, our laptops, it try to communicate with the local DNS server, that query is always the recursive.
Okay.
Recursive means I'm telling to the local DNS server, I need IP address of www.facebook.com. So I don't know from where you are taking. I don't need any suggestion like I need to go that place, I need to go that place. I need the IP address of www.facebook.com. I don't know from where you are giving. Recursive means whatever things you are requested, I need the actual details. That is called recursive. In case of iterative, whatever query happen after local DNS like root, top level, we can authoritative servers, that query will be always the iterative. Iterative means I need IP address of www.facebook.com, but root server is telling, okay, I don't know IP address, but I can guide you where you need to go. That is called iterative query. Recursive means I need IP address and I want from you. I don't want any suggestion and a step. Okay, we need to go there. We need to go there. No, that is called recursive. So this is the difference between iterative and query and recursive query. And this is how it is designed. And if it will not design like that, maybe it will not create a stable solution for us, because every time for example, some application I'm accessing, but that entry is not available in our local DNS. Always it is going to be okay if this local DNS starts sending recursive query to root server. But root server is not the IP address www.facebook.com, because it is hosted on the some authoritative server which is managed by some another organization or maybe our organizations. So now root server is going to be send that query to the top level and authoritative, take IP, give to the local DNS. So this is not a stable and we can say like good solutions. So that is the reasons after local DNS, whatever query happen, that is iterative. Before local DNS, client and local DNS communication always happen as a recursive. So this is the basic difference between the iterative and recursive.
Yeah. And between local DNS and root server is a query also recursive, right?
No. Recursive query is always between client and
Server
local
only.
DNS server.
Local DNS
Yeah.
only, yeah.
Local DNS to root, top level, authoritative, all are the iterative query.
Okay, so whatever local DNS sends to root DNS, root server, that is also iterative. And
Correct.
root DNS as response to local DNS, right? So that is also iterative.
Yeah.
Okay.
Recursive query in between our client and the
Local DNS.
local DNS. Yes. Recursive means in short and simple, whatever I requested, I need details. I don't need any suggestion, any step. Okay, so this is the short overview about recursive panels. Then we'll try to see DNS terminology. We have like domain names, we have subdomains, and see this is the DNS hierarchy. So I mentioned like root level, top level domain like .com, so .net, .org. This is your top level domain, and root level is basically any website at the end mentioned dot. It's not visible, but at the end it is mentioned dot. That is called root level. Top level domain is multiple domain. Then second level domain, for example, so, um, facebook.com, youtube.com. That is second level domain. Subdomain like, for example, www.facebook.com, www.f5.com. So these are the subdomains. So this is the DNS hierarchy. It is how, see like how it is designed, you can say. In DNS terminology, we will see like DNS lookup, name server. So name server is basically the server where we generally maintain the records like A records, four times A records, C names, all will be there on our record on name server, right? And so when that is the reasons when top level domain server reply, okay, I don't know the IP address, but I know where you need to go. So that query go to the name server or authoritative server. Then that will give the IP address because that is the actual place where we bind our IP address with applications. For example, www.facebook.com is binded with 888888. Then that server will give IP address to the local DNS, and then local DNS is maintained in its cache and sent to the user. When next time any people come for that application, it will directly give from local DNS. It is not going to be followed again same process. This is the name server. Then we have some records like 4 times A records. Basically, it is for the 4 times A means it is for the IP version 6, and A record means IP version 4. Then you have CNAME. CNAME basically is very important, especially if you guys are working on F5, especially like LTM, DNS, WAF. WAF is widely used. So my work is on WAF also. So CNAME is basically play a vital role. I'm just giving little overview. For example, any user is trying to access www.facebook.com. Okay. So on DNS, we defined it. On DNS, we define like if anyone try to access this, please point this to this CNAME. Maybe let's consider facebook.com. So user is requesting to access this application, but the actual query is handled by this. Okay. So now with the help of CNAME, this query will come to the, maybe in our case, will come to the F5 DNS. And then F5 DNS will check, okay, then wide IP configured for this CNAME. Yes, we have wide IP configured. Wide IP basically the FQDN. Okay, so inside wide IP, how many poles? Let's consider we have 2 poles. Let the VIP IP 10, 10, 10, 10, 10, and another VIP IP is 10, 10, 10, 10. Just consider 12. As per the availability, as per the load balancing method, if it is round robin, F5 DNS is going to provide this IP to the user who requested to access www.facebook.com. So this is the CNAMEs. With the help of CNAME, we can modify the traffic. We can say like manipulate the traffic towards our devices. You are accessing facebook.com, www.facebook.com. With the help of CNAME, we pointed to send that query to another devices where actual DNS is hosted, where actual DNS record is hosted. That's called CNAME. It is canonical name. It is working on behalf of actual, we can say like URL.
So, Surya, this CNAME term is similar to the common name in FLTM.
No, common name is basically good questions. So common name is basically the common name is basically not the canonical CNAME. Common name is basically your actual applications. Let's consider www.facebook.com. Common name is used for actual applications which is hosted behind your load balancers. So we have 3 Facebook server, this is our load balancer F5 LTM, and 3 backend server is there behind our load balancer, and all 3 are the application server, Facebook application server. This user is trying to access facebook.com. This user had no visibility who is in the middle, because our LTM box is working as a reverse proxy. So whatever IP address of this DNS, whatever the IP address of this facebook.com added in DNS entry, just for example, this IP address is 10.10.10, www.facebook.com IP address is 10.10.10.10. That IP we created VIP on the LTM box. So when user is trying to access www.facebook.com, DNS server will give IP address of this. Then this user will start communicating with this IP. Then the traffic will come to the F5. F5 is going to be sent to the backend server as per the load balancing method. So in case of LTM CNAME is the actual actual application which is hosted behind our load balancer, not the canonical one.
Okay.
But canonical, with the help of canonical name, we can manipulate the traffic. For example, if anyone try to access facebook.com, but we don't want like this query is handled by this server. We want like if anyone try to access this, please send this traffic pointed through the CNAME, and the CNAME is hosted on our devices. Like we have created wide IP for that, and then F5 DNS will provide the IP address. So while doing that, we are manipulating this traffic to come to our devices. So that is called CNAME. Okay,
Right.
it is working on behalf of actual application.
Okay.
Okay, perfect. Okay, then we'll see like what in DNS record I have told you guys, but in name server record. MX record is related to mail server. So not much important, but yes, just for the understanding purpose, MX is a mail exchange records, direct email to server for domains. Multiple MX record can be defined for a domain, each with a different. We'll see. When we'll do lab, we'll see. We'll try to use like one more thing I want to show you guys. Yeah, I'll see in sometimes. Okay, so this is the important thing. This is the important points. This is the traffic flow of F5 DNS. If you know this, means you know F5 DNS. F5 DNS is not big topics like LTM. Okay, it is a small. Just 1 minute. I'm deploying one Linux machine for you guys so that I can see some. I can show some dig command. So I'm deploying one Linux on the Azure. Maybe it will take 5-10 minutes, and meanwhile we can go further. So okay, just 1 minute. I'm launching. I'm doing on another PC, guys, so I can't show that part, but we'll try to do SSS, so that part we guys can see. It will take 5-10 minutes. Okay, so this is the traffic flow. So if you know this traffic flow of F5 DNS, for example, see if any DNS query come to the big IP on our DNS listener IP. So basically, listener IP will configure on the client machine in our lab environment in DNS space. We can say like DNS place. So while can I configure IP address, we have the option like primary DNS and secondary DNS. So listener IP is just the VIP IP, whatever we configure on the LTM boxes. Okay. So you guys already know F5 LTM. So that is the reason I asked in the beginning. If you know LTM, then you can easily understand the flow and easily we can understand the flow of DNS. So listener IP is basically nothing. The VIP IP is similar like whatever we configure on the LTM box. So when DNS query come to the big IP, it is going to be check, okay, if there is any wide IP configured for that FQDN. For example, someone is trying to access www.facebook.com. So we generally created the wide IP for www.facebook.com. It is going to be check, is there any wide IP there? If yes, how many pool is there? Accordingly, it is going. Accordingly, it is going to give the IP address to the client. Okay. Let's consider there is no any wide IP is configured. Then it is going to be check, okay, either in DNS Express zone is configured. What is DNS Express zone? We'll see in detail, don't worry. So DNS Express zone is, in case of DNS Express zone, F5 will act as a secondary DNS server and some another DNS server will act as a primary DNS server. Just for example, maybe your Linux machine, maybe Windows machine, that is the primary DNS server, and all the details is fetching to the local secondary DNS server, that is our F5 DNS. It is going to be checked if there any DNS Express zone is configured. Zone is basically, guys, domain. For example, example, just consider facebook.com. Don't confuse here from zone. Zone is basically the domain. So it is going to be checked either in Express zone is there. If yes, it has the details of that FQDN. Yes, it is going to give IP to the that client. Just one. So, is Ubuntu machine, that is fine. Let me do the password. Fine. Okay. So now it will be created in 2 minutes. So almost Linux machine is deployed. So this is the flow. So if just consider if DNS Express is not configured, then it is going to be check the DNS cache. Is there any cache for that applications? www.facebook.com on our F5 DNS box. If yes, it is going to be give IP to that. Just consider if there is no DNS cache, it is going to be resolving cache is defined. If not, again it is going to be listener has a pool. What is listener has a pool? So for example, while creating listener, we inside the listener there is option to create pool. Inside the pool, we can mention our DNS or IP address. We can mention our DNS or IP address. So it is going to be check, okay, if there any listener for this listener, if there any pool has configured, inside pool you have done DNS server. We can say like if yes, it is going to provide IP address of that. Basically, pool means basically we define the, just consider maybe our DNS server, maybe the actual IP which is binded with that applications. So generally in pool, we generally put our DNS server IP address, and then DNS server will give IP address to the users. So this is the flow. Then it is going to check a DNS profile allow local bind. No. Then it is going to check, okay, Linux listen not a self IP. If not, If yes, it is going to be provide the IP address to the user. If not, it is going to be give the request timeout error. So this is the normal overview, or we can say like F5 DNS traffic flow. But to be honest, in company guys mostly use this part, wide IP, and then sometimes you can see this ones. We don't need to focus on all. This is just the traffic flow. So in our lab, we'll see this one. It is very, very important, and mostly 99% organization use this one. So if anyone try to access any application, that query will go to DNS. That query will go to our F5 DNS. F5 DNS will create a wide IP. Inside wide IP, will create our VIP IP. VIP IP, which is hosted on our LTM devices, created on LTM devices, and that VIP IP will be provided to the user, and user will start communicating with that VIP, and traffic will handle by the backend server, which is hosted behind our LTM boxes. But these are the flow, so we can just know just for the awareness purpose. We don't need to focus much here. Then we'll see like this is the use case of the big IP DNS features like DNS Express Zone, ZoneRunner, DNSSEC. So we'll see this part. DNS Express, ZoneRunner, DNSSEC we'll see at the end. DNSSEC will come in the end. Then we'll see some troubleshooting tools also. This is how DNSSEC works. So this is just the normal diagram. So we'll see in details. And let me show some command. We see some we'll see some NS lookup, and we'll try to use D command also. So you guys know what is the difference between NS lookup and D command? We know the difference.
NS lookup and
DIG.
I'm sorry.
Okay. No problem. I'm explaining that only. I'm just trying to access my virtual machines through SSH. Okay, so its IP is 20, so you can do SSH. Okay, so this is our Linux machine, guys, because D command is by default installed on our Linux machines, but it is not installed on our Windows. But there is some steps. Maybe I'll share with you guys some. There is one link of YouTube channel, so we can follow that, and we can install the D in your Windows machines. If you have the Linux machine, you don't need to install the D command because by default it is already installed. But in case of Windows, we need to install it. So NS lookups we already know, right? So let me open another command prompt here, and that will be our Linux one. And this will here we'll see D, here we'll see NS lookup. So this is the utility we use for the DNS troubleshootings. So for example, NS lookup. If you want IP address, DNS lookup, www.facebook.com. I'm not getting any IP address. Maybe you are this URL is, I'm not sure how it is deployed. Facebook people can only know. Let's try another. NS lookup. I just run NS lookup and I am telling I need IP address server. So I have set the server 888. Means now I am asking the IP address of facebook.com. So I got the IP address of facebook.com. So what I did, I run the NS lookup. Then I set server 888. Means I'm not asking that detail from our local DNS server. I'm asking that detail from 888. I need IP address of facebook.com. That is the reason I get answer as non-authoritative. What is non-authoritative? Non-authoritative means whatever request I have done, for example, whatever details you requested, that is not available in my side. I am taking from someone and then giving to you. So I'm not the authoritative people for that. Someone is authoritative for that. So that is called a non-authoritative answer. Means this detail is coming from another people's. For example, I am accessing www.facebook.com. So I am doing NS lookup for www.facebook.com, and that detail is getting from my local DNS server itself. For example, that entry is maintained on our local DNS itself. In that case, we can give authoritative answer. But in case of non-authoritative means that detail is taken from someone else. Okay. Similarly, we can take www.youtube.coms. So these are the IP address. So who is giving? I'm taking from 888. 888 is giving, but that 888 is taking from someone else because that entry is not maintained on 888 DNS server. It is maintained on some another DNS because of course it is Facebook and 888 is Google DNS. So common, this is the common things, right? So this is how NS lookup. So with the help of NS lookup, we can resolve our IP to FQDN, FQDN to IP. We can check our DNS entry. We can check which IP is binded with which applications. Accordingly, we can do troubleshoot. We can trace out. So it depends upon the design, issue, troubleshooting, like which types of issue you are doing. But yes, without IP, we can't do troubleshooting. So you guys are already working, like you guys are all working professionals. So if you're doing any troubleshooting, any deployment, first we generally do NS lookup. In case of F5, it is very, very important because if you are working on any P1, P2, they will give the FQDN. Okay, this application is hosted on your F5 devices, and at the moment it is not accessible. So what is your first step? First step is do the NS lookup of that applications, get the IP address, check, okay, that IP is created as a VIP on all LTE boxes. Yes, check the status of VIP, check the status of pool, check the status of pool members, check the traffic is coming or not, try to do TCP dumps and all. So these things we can do on the with the help of NS lookup. Just 1 minute, guys. So this is about the NS lookup. Dig is also do the same work, but dig is mostly used at the times of troubleshooting. So dig has the more details. For example, I am trying to dig here, dig www.facebook.com, and I'm asking that detail from the Google DNS server. See, so how many things in the result, if you see the comparison of NS lookup and dig, how many difference we are able to see? In dig, we are able to see timers, like how many time it take to give the reply. Okay, and including everything like how many query we have sent, how many insert we have, how many authoritative additionals. We can see like once we start doing DNSSEC, we'll see here, okay, this is the encrypted one or it is a plain text kinds of things. So in dig, we can see more result in details and the compare of NS lookup. In NS lookup, we can see the IP address only, but in dig, we can see so many things like uh, how many seconds it is very, very important to take, okay, how many time it taken to give the IP address. And so we can similarly do for the another application like dig www.youtube.com. And we are asking at that times, let's consider another server. I'm asking 4.2.2.2. This is also open DNS server, right? So this is the IP address of youtube.com. There's so many IP. This is the C name. Basically, EA means it is kinds of EA records. This is the IP of. This is how they maintain of www.youtube.coms. There are so many entry they have. So this is the actual domain, and they have created like uh, these are the we can say like record on their DNS servers. These are the we can say like um, the YouTube dash UI. So they have created multiple record inside these domains, and these are the IP address of that. So it totally depends like how DNS has designed at their side. But with the help of dig, we can do deep dive. We can see multiple here, multiple things here, and the compare of NS lookup. And another things with the help of dig, let's try to do dig www.facebook.com, and we'll try to ask from the open DNS server. This is the open DNS server 9.9.9.9. Okay, so we have run I think 5 times. We need to run it 4 times only, right? So see, we get the IP address of facebook.com. So this is the FPDN. We have requested IP address for that. This is the IP address. This is 2 milliseconds text. Okay, and everything servers. This is the open server. This is the timing. So each details we show in dig. So this is the basic difference between dig and the NS lookup, guys. Okay, so once we start like from tomorrow in details, first we'll try to see. First we'll see like our first lab will be our big IP DNS as a recursive DNS server. Means we'll configure our F5 DNS as a recursive DNS server. So for example, any PC trying to access www.facebook.com, that request will come to the F5 DNS. F5 DNS is going to fetch that detail from Google DNS and send to the user. So whatever I explained in the beginning, what is the difference between recursive and iterative query? So when we configure our F5 DNS as a recursive DNS server, at that time, F5 DNS will act as a recursive DNS server, but it will take IP from another DNS server, like Google DNS server, Facebook DNS server, Open DNS server. And when run the dig command, it will see, or NS lookup, it will show non-authoritative DNS server, because we will request the IP address facebook.com. That query come to our F5 DNS. F5 DNS will take from the normal Google DNS server like Facebook or Open Google DNS server or Open DNS server, and that detail come to the F5 DNS. F5 DNS will send to the user, and then user will start communicating with that IP. Okay, so tomorrow our lab will be that F5 DNS will configure F5 DNS as a recursive DNS server, and then accordingly we move ahead like another content, another topics. We'll try to see in details with some example and all. So accordingly we'll design our lab. So tomorrow I will design our lab like that. But I can give little bit overview how will be our lab look like. So, but not the actual one. We'll see our IP address is different and IP schema. So let me show you. I think I have somewhere. Do not use this one, but it's can't so. Let's consider. So this is we'll try to create 3 data center. One data center where our GTM will be hosted, and will create two data center where LTM boxes will be hosted. The two LTM boxes will be hosted on data center 1, data center 2. One GTM box will be hosted on another data center. Let's consider this is the PC. So when this PC trying to access, for example, www.simpledomain.com. So we will create wide IP for this FQDN. That request come to the F5 GTM. That is now it is called DNS. Inside wide IP will configure pool, and inside pool will define this IP 192.168.175, 192.168.176. This live is for the GSLB, global server load balancing, not for the recursive DNS server. But I'm just trying to show like how many diagram, how many topology will read that. So this is the example of GSLB, because this data center is considered in India. This is US. This DTM is hosted on maybe US or India. Just consider like that. Then it is going to be checked the how many wide pool is configured inside wide IP. So two pool, VIP IP 192.168.1.175, 192.168.1.176. This IP is the VIP IP which is configured on the LTM boxes. So now DNS will give IP address as per the round robin method. First time it will give IP address 192.168.1.175 to the user. Now user will start communicating with this IP. Traffic is handled by the backend server. So F5 DNS only role to provide the IP address of the VIP. Apart from that, it is not going to do anything else. Okay. So 1 minute. Maybe I can explain here. Yeah. So once this PC will try to access our facebook.com. In our lab example, this will the FQDN www.safe.com. We have created wide IP. Inside wide IP, we have mentioned these two pool. As per load balancing method, this IP will be given to this user. Now this user will start communicating with this, and traffic will handle by the backend server as per the normal load balancing method, whatever we configure on the LTM boxes. So this lab will use for the GSLV, and for recursive DNS server, it will be kind of different, because in recursive DNS server there is no any concept like data center and load balancing kinds of things. It is simply act as a recursive. It will take the IP from the open DNS server and give to the user. Usually start communicating to that application server.
Okay.
So that's it. So this is about the overview, guys, like how many things we are going to cover, which topics, how many, which types of topology, and we'll see everything one by one as per our content. So I hope you guys has little bit idea about F5 DNS, normal DNS, right?
Yeah.
Najir, you have any